here's the first part of our chemical reaction equilibrium lab. You're going to watch the video again. Going to pause very often to answer questions in the worksheet, in the lab data sheet. So the first part is to test, to study what factors will influence our reaction rate and in what way. Okay, so I'm going to show you in different conditions, and you can see the reaction rate by watching the reaction. In this case, it's the bubbling because gas is forming. So you're going to see if the bubbles form violently or slowly to decide if the reaction is faster or slower under different conditions. Okay. So the first condition, first factor we're studying is the nature of the reactant. So if you look at the procedure, we're going to have the same reactant as the acid, but we're going to use different metals. This is the zinc metal, this is the copper metal. So you're going to say react with the same acid, 6 molar hydrochloric acid, which one going to have a faster reaction. So we're going to take the acid, this is the 6 molar hydrochloric acid. Another one also 6 molar. Okay, so one I'm going to put the copper into it. Another one I'm going to put one piece of the zinc in there. Okay, so you can see the reaction. One is already started, another one is nothing happened there. Okay, all right. Then I'm going to put the rubber stopper here. I'm going to hold what the gas is forming. Okay. So I may need to do another one, but you can see this. This one seems like no bubble forming, so we can save our energy for that part. We can just quickly test there. Okay, so now I'm going to test it by ignite the wood splint. I'm going to use the matches instead of like the menu says Bunsen burner, and then I'm going to test what's the gas there. I'm gonna burn the gas to see what's going on. Okay. All right. So I'm going to hold this one, but this one seems like no anything, so you can just quickly test it. Nothing really happened because there's no any gas there. But this one we do have a lot of gas in. Ooh, you hear that? So that something is burning in there. What's that something? That's the hydrogen gas is forming, and the hydrogen gas burned normally give us small explosion. So that's why you see that. Okay, so now we stop that. We take those away. That's our first factor. Okay, so in the question, you needed to cite the evidence of the reaction, what you see there, to give you the proof it's reacting. Another one, question 4, down there, it's asking you to complete the balanced equation. Okay, and then you're going to write down the reactants, products, and also you needed to balance them. Okay, now let's move on to next the factor, concentration of the reactants. So this time we're going to use the same zinc metal, but we're going to use different concentration of the acid. So one 6 molar hydrochloric acid, another one 1 molar hydrochloric acid. Okay, so we're going to put the zinc metal in there. So put in there. 1 piece, 6 molar, 1 piece, 1 molar. You can see which one is faster reaction here. Kind of obvious, right? I can shake a little bit to help you to see the reaction. Another one, you can see this one I'm holding, it's slower, but it do have some reaction on the surface. You can see some of the bubbles forming. You can see the speed is gradually forming. So you can see which one is faster, which one is slower. Remember, this is 6 molar hydrochloric acid. This is 1 molar hydrochloric acid. Okay, so you're going to identify which one's faster in question 2. In question 3, you're going to give a general trend. So in this question, do not just repeat what you see. You are going to conclude from what you observed. Okay, so you're going to give a general trend about the concentration, how the concentration influenced the reaction rate. Put in one sentence there, okay. Now let's study another factor of the reaction. So we are going to have the temperature difference. I'm going to take those away. Watch that. So this time we're going to have a room temperature 6 molar hydrochloric acid. Another one is the ice bath, cold, same concentration, 6 molar hydrochloric acid. It's just, what's the difference? Different temperatures. Okay, so this time I'm going to use the zinc to react again. So we're going to see the reaction in there. So this one's already cold, so I'm going to take that out. So you know that one is cold. Okay, now I'm going to put a metal in one, and another one is zinc metal. You can see the reaction difference, same concentration this time. So you can see one faster than another one, right? Which one? Remember, this is the room temperature, 6 molar. This is the cold, ice cold, 6 molar. Okay, so we see the temperature difference. All right. Now you're going to do the same thing, answer those questions by posting the video. Okay, now I'm going to take those away. If you want to take a nice look at that, you see the difference? Okay, very obvious difference. All right. Then this is hydrogen peroxide, 3%. So this is going to be our catalyst factor. This one just hydrogen peroxide here. Okay, so you can see we wanted to loosely stop it. Okay, but actually you can see it's I put outside for a while just the several bubbles on the wall. Okay, then let's try if there are any gas form in there. Okay, oh, can use the same splint. Maybe it's already accumulated in the tube. Yeah, gas is invisible. Okay. What I'm doing is follow the procedure. I'm going to check the gas by ignite the splint, get rid of the flame and just the glowing part. Just put in there. So nothing really happened. You can see that pretty much the same thing, okay? All right. Then I'm going to add a catalyst to see the difference. Now we are going to have a catalyst involved in this reaction. I'm going to just shake some of the manganese oxide in there. Put some, we just need some catalyst. Ooh, something happening. I'm going to put a stopper. Accumulated the gas. Later we're going to check. You see that with the catalyst, you see the reaction is different. The rate is changed. Okay. Now we're going to see if there are any gas formed. What kind of a gas is forming? Would you expect to hear the pop again, or this time it's a different gas? Okay. Let it glow in. Ooh, reignite. Do it again. Ooh, reignite. What gas will support the combustion? Think about it. Okay, all right. So you can see catalyst really make a big change in the reaction.